In this lecture here, we want to talk about how you solve other types of equations. So what I'm going to be working with in this lecture here is, we've talked about how you solved linear equations, how you've solved, quadratic equations. So in this one here, we're going to handle different types, and there's going to be a lot of different methods. And the way that you get good at these type of problems is with practice. So after you watch this lecture, you should go and you should practice these problems. And you're going to notice that there's a lot of common tricks and themes to specific types of problems. Okay, so here's what we're going to work through. We're going to talk about how you solve polynomial equations by factoring. So how you're going to solve radical equations, how you're going to solve equations with rational exponents. So what this means, this rational exponents, is something with like x to the m divided by n. So it's a fraction as an exponent. And then we're going to solve equations with the absolute value sign. Okay, so solving by factoring is going to be the first one here. So these polynomial equations is the result of setting two polynomials equal to each other. So you'll see in the examples here when I get through them. So the equation is in general form if one side is 0 and the polynomials on the other side is in descending order of the variables. Okay, and so we know the degree of the polynomial equation is the same as the highest degree of any term in the equation. So going back here, so what you're hinting at here is we want to put in general form. Okay, so that's what we're going to do. We're going to put the equation in general form first, and then so this means you're going to set one side equal to 0. And then I'm going to show you how you're going to solve by factoring here. Okay, so here's going to be the first one here. So let's look at 2x cubed plus 3x squared is equal to 8x plus 12. All right, so first thing I want to do is I'm going to move this to the other side. So I'm going to subtract it over. All right, so put in general form. So I have 2x cubed plus 3x squared minus 8x minus 12, because I subtracted this over, is equal to 0. Okay, so notice how you have a 4-term polynomial, so you're going to factor by grouping now. So I'm going to group the first two terms together. So 2x cubed plus 3x squared. Now notice when I do this minus here and then I put a parenthesis, it's going to change the sign. So this minus 8x is 8x, and this minus 12 becomes plus 12. Okay, so factor here, what are you going to factor out? You're going to factor out an x squared here, right? So you're going to be left with 2x plus 3. You're going to factor out a 4 here, so minus 4. You're going to be left with 2x plus 3. So then notice how they each have a 2x plus 3. Now here's what's interesting. Look what's left. X squared minus 4. Well, does x squared minus 4 factor? Yes. Yes, it does. It's the difference of two squares. So it's going to factor into x plus 2 times x minus 2. Now look here. All right, you're going to use your zero product rule here. So, I have something times something times something equals 0. So then either this 2x plus 3 is equal to 0, or this x plus 2 is equal to 0, or this x minus 2 is equal to 0. So over here you would subtract 3 and then divide by 2. Over here you'd subtract 2. And over here you would add 2. So this right here, I'm just going to put it in order, has 3 solutions to this equation right here. And you could plug all these in and check to see if they work, and they will for you. So you just solve by factoring. All right, let's try this one now. Let's look at another one here. So let's look at 2x to the 4th is equal to 16x. Okay, what you do not want to do, or you don't want to just start by saying, oh, let me just divide by x. Don't do that. Subtract the 16 over 16x. Now factor. Okay, so what I can do is I can factor out a 2x, and I'm left with what I believe is x cubed minus 8. So I have something times something, and it's equal to 0 here. So look, I have either 2x is equal to 0, or this x cubed minus 8 is equal to 0. Well, look, just divide both sides by 2 here. One solution is x is equal to 0. Add the 8 over. Well, what number cubed gets you 8? Well, that's 2. 2. So my solutions here, I have 2 solutions. Either x is equal to 0 or x is equal to 2. Both work here. All right, let's try this last one here. Let's look at 2x minus 3 is equal to 8x cubed minus 12x squared. All right, so you're going to notice it's going to be solved just kind of like this one here. So what I'm going to do is I'm going to subtract the 2x over, and I'm going to add the 3 over. So I'm left with 8x cubed minus 12x squared minus 2x plus 3 is equal to 0. So I'm going to factor by grouping. So I'm going to group the first 2 terms together. Remember, when you put the negative here, you're going to change the signs. Okay, what am I going to factor out here? Well, it looks like I'm going to factor out a 4x squared, I believe. I'm going to be left with 2x minus 3. I can factor nothing out of here, so I'm going to put a 1 here. It helps me see it. So look, this is where it gets a little interesting. Believe it or not, this 4x squared minus 1 is a difference of 2 squares. So it's going to be, here this looks like it's 2x squared minus 1 squared. So this is going to factor as 2x minus 1 times 2x plus 1. And so look, just like here, you can see what happened, right? You're going to get 3 solutions here. So either 2x minus 3 is equal to 0, or 2x minus 1 is equal to 0, or 2x plus 1 is equal to 0. So add the 3 over, divide by 2. So one solution is x is equal to 3/2. Add the 1 divided by 2, x is equal to 1/2. Or subtract the 1 then divided by 2. And these are your solutions. All right, so you can see that x is equal to minus 1/2. I'm just putting it in ascending order here. 1/2 or 3/2. And there you go. All right, so the key there, just solve it by factoring there, and set it up, and you'll be okay. All right, let's move on to a different type of equation. So let's talk about a radical equation. So a radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. Okay, we solve radical equations with nth roots by raising both sides of the equation to the nth power. And so generally what I'm going to do, you're going to see here, is I'm going to work with square roots here. But if you had a problem with the third root, you could just raise it to the third power. Okay, so like for example, if you had something like the third root of x minus 1 is equal to 2, what you would do to solve this is you'd say, okay, well, I have the third root. So I'd raise it to the third power, get rid of this, so you'd be left with the third root cubed goes away. They cancel each other out. So your x minus 1. And then look here. 2 cubed is 8. And then you add 1 to each side. And you get x is equal to 9. And then this is really important. You need to check your solutions. So my original equation was the third root of x minus 1 is equal to 2. Well, if I plug the 9 in, yeah, this does work out. All right, so I'm going to work some of these problems, and I'll start with some relatively easy ones, and then you're going to see they're going to get harder and harder and harder. All right, so here's how you're going to solve. So if necessary, arrange terms so that one radical is isolated on one side of the equation. So you want to isolate one radical. You want to raise both sides of the equation to the nth power to eliminate the isolated nth root. Okay. Then you're going to solve the equation. If the equation still contains a radical, you're going to have to repeat it. So I'm going to do a problem. You're going to see where you're going to have to square it twice. And it's a little, it's not always the most fun, but we'll get through it. And then really important, you need to check all proposed solutions, okay? So you need to check. Okay, you need to check. All right. So we'll start with some simple ones, and then we'll go from there. All right, so let's look at this one here. So the square root of x plus 3 is equal to x. All right, so the first thing you're going to need to do is isolate a radical. So what I'm going to do is I'm going to subtract 3. So I'm left with the square root of x plus 3 is equal to x minus 3. All right, now to get rid of this square root, what you're going to do is you're going to square both sides. So the square root square cancel. You're left with x plus 3 is equal to. You have to FOIL this out, okay? So this is x plus 3 is equal to x squared minus 6x plus 9. And then what you're going to have to do, okay, is you're going to have to subtract and isolate. Now you just have a polynomial equation, right, that you need to solve. So these all cancel. You're left with 0 is equal to x squared minus 7x, and this is plus 6. So you're going to have to solve this by factoring, right? So this is going to factor two numbers that multiply to positive 6, sum to negative 7 is x minus 6, x minus 1 is equal to 0. So your two solutions here, okay? Your two solutions. One solution is x is equal to 6, and you can see here another solution is x is equal to 1. All right, so here's the really important thing, right? Like you have to check. Like if you plug 1 into this, you get 1 plus 3 is 4, okay? Square root of 4 is 2. 2 plus 3 is 5. Does 5 equal 1? No, this does not check out. But if you plug the 6 in, okay? 6 plus 3 is 9. Square root of 9 is 3. 3 plus 3 is 6. That does equal 6. So this one checks. Let me do another one. Let's look at the square root of 3x plus 18 is equal to x. We'll do a little simpler one here. So what you're going to do is you're going to square both sides. All right, so the square root and square is going to get rid of each other, like so. Then what you're going to do is you're going to subtract all this over to the other side. So you get x squared minus 3x minus 18 is equal to 0. So you know what two numbers multiply to negative 18 sum to negative 3? Well, that's x minus 6 times x plus 3. And that's equal to 0. So you get two solutions, right? You get one is x is equal to 6, or you get another one, x is equal to minus 3 when you solve this. And look, this was my original equation. 3x plus 18 is equal to x. Well, negative 3 won't work. Like you can't get a square root here to get this negative 3. So this negative 3 will not work. So the only solution here is 6, right? Because if you plug 6 in, 3 times 6 is 18, plus 18 is 36. Square root of 36 is 6. So this negative 3 doesn't check. All right. So let me do a really hard one now here, but it's going to involve squaring twice. All right, so let's try this one. Let's look at the square root of 2x minus 3 minus the square root of x minus 2 is equal to 1. All right, you have to be very careful here. So the first thing you're going to do is you're going to isolate a radical. So what I'm going to do is I'm going to add this to the other side. And now here's where it gets confusing. Now you're going to square both sides. So this is easy, right? The square root and square go away. You're left with 2x minus 3 is equal to. This you have to FOIL out. Now this is where it gets, you have to be very, very careful. So this is still 2x minus 3 is equal to 1 times 1 is 1. 1 times this. Now square root of x minus 2 times 1, you get another square root of x minus 2. Now you have to ask yourself this. What is the square root of x minus 2 times square root of x minus 2? Well, that becomes, so when you multiply here, that becomes the square root of x minus 2 squared, which is just plus x minus 2. Awesome. All right, now let's clean it up. So I have 1 minus 2, so I have minus 1. I have this plus x. And I have 2 over here. I have 2 plus 2 times square root of x minus 2. So what are you going to do now? Okay, I know it gets a little confusing here. Okay, so now you're going to add the 1 over, and you're going to subtract an x. So these cancel. So 2x minus x, I'm just going to move it over here, gets you x. Minus 3 plus 1 gets me minus 2 is equal to 2 times square root of x minus 2. Now you're going to have to square both sides. All right, so x minus 2 squared, I'll let you FOIL it out, but you end up getting x squared minus 4x plus 4 is equal to, now here's where it gets confusing. Square, you're going to square the 2. The 2 squared becomes 4. And then square root of x minus 2 is x minus 2. So now distribute. Okay, so what are you going to have to do, right? You're going to have to subtract over. So you get x squared minus 8x plus 12 is equal to 0. So you're going to have to factor this. It factors into x minus 6 times x minus 2 is equal to 0. So you have two solutions, right? One is x is equal to 6, or another is x is equal to 2. Okay, so you have to check. You have to check this, okay? So let's check this, right? If you plug 6 in, you get 2 times 6 is 12, minus 3 is 9, the square root of 3, or square root of 9 is 3, minus, and then you plug 6 in, 6 minus 2 is 4, square root of that is 2, and that does equal 1, so this checks. And now if you plug in 2, right? So 2 times 2 is 4, minus 3 is 1, so the square root of 1 is 1, minus, well, this one also checks out. 2 minus 2 is 0, so 1 minus 0 is 1. So they both check out. So that's good. That's good. So it's a little bit harder, and you notice you have to be meticulous in the algebra, because if you make one mistake, it's going to be wrong. Okay. So now let's move into some different types here. All right. Now let's talk about rational exponents. So we know that rational exponents represent radicals. So here, what I'm saying here is if you have a raised to the m divided by n power, there's two ways you can write it. It's the nth root of a to the m power, or the nth root of a to the m. Okay, so this is going to help us solve. Okay, so a radical equation with a radical exponent can be solved by isolating the expression with the rational exponent, or excuse me, I think I said radical exponent, rational exponent, and raising both sides of the equation to a power that is the reciprocal of the rational exponent. All right, let me show you, okay, because it seems a little confusing at first. All right, so let's solve this one. Let's look at x to the 3/2 is equal to 8. All right, so I want to solve for x. So notice how I have 3/2 here. So what I'm going to do is I'm going to raise both sides to the reciprocal. So the reciprocal is 2/3. So whatever I raise to one side, I have to do to the other. Now here's what happens. So power to a power, you multiply. So this is x to the 3/2 times 2/3 is equal to. Now how are we going to solve this? Well, this is the third root of 8 squared. Well, 3/2 times 2/3, that's just 1. So x to the first power is equal to. Third root of 8 is 2. So 2 squared. So you end up just getting x is equal to 4. And look, if you were to check this, right? If you were to plug 4 into this, well, the 2 in the denominator here, it says square root it. Square root of 2 is 4. And then you would cube it. Or square root of, square root of 4 is 2, excuse me. And then if you cube it, you get 8. All right, let's try this one. Let's look at 6x to the 5/2 power minus 12 is equal to 0. All right, so you're going to isolate this. So add the 12 over. Divide by 6. So you get 2. And then look, you're just going to raise both sides to the reciprocal of this. So this, just notice that these are just going to cancel out, and you get left with x is equal to. You're just going to leave this as this, 2 to the 5th, or 2 raised to the 2/5 power. So you could also rewrite this as the 5th root of 2 squared, which is, the 5th root of 4, you could write as. But you can also just leave it like this. All right, let's try a harder one here. Okay. Let's look at let's try this one. Let's look at x plus 5 to the 2/3 is equal to 4. All right, so what are you going to do? You're going to raise both sides to the 3/2 power. So these are going to cancel. So you're left with x plus 5. Well, remember this. The 2 down here means square root it. Square root of 4 is 2, and then 2 raised to the 3rd power is 8. And then you're going to subtract 5. And boom, you just get 3. And if you were to plug this in, you will see it works out, right? Because 3 plus 5 is 8. Third root of 8 is 2. 2 squared is 4. Boom, checks out. All right, let's try this crazy one here. Let's look at x squared minus x minus 4 raised to the 3/4 power minus 2 is equal to 0. Okay. Add the 2 over. We want to isolate it. Then you're going to raise both sides to the 4/3 power. I'm sorry, this is 8. Forgive me. A little bit of a typo there, not 2, 8. All right, so these cancel. So you're left with x squared minus x minus 4 is equal to. All right, well, now just be careful. What is the third root of 8? Third root of 8 is 2. 2 to the 4th power gets me 16. Now subtract 16 to both sides, because you see it's a simple polynomial equation. You get x squared minus x minus 20 is equal to 0. Then this is going to very, very simply factor, right? It factors two numbers that multiply to negative 20. Sum to negative 1 is x minus 5. X minus 4 is equal to 0, or excuse me, x plus 4. So then my two solutions are 5 and negative 4. And we got it. So you just see, like, once you get it here, right, it's easy from here. Okay? But, you know, the trick is to get it there. So you have to just remember how to handle these problems. All right, so you just raise to the reciprocal. All right, let's just finally talk about absolute value equations here. Okay, so the absolute value of x describes the distance of x from 0 on a number line. To solve an absolute value equation, we rewrite the absolute value equation without absolute value bars. Okay, so it's a little tricky here. So if c is a positive number, so I'll show you what happens if it's a negative number in a bit, and u represents an algebraic expression, then the absolute value of u is equal to c is equivalent to these two solutions. U is equal to c, or u is equal to negative c. Okay, so you're going to have to set up two equations to solve, and you'll get two answers, and that's okay. All right, so let's solve this one here. So I have absolute value of 2x minus 1 is equal to 5. So using this, right, absolute value of u is equal to c. So one solution is that 2x minus 1 is equal to minus 5, and another solution is that 2x minus 1 is equal to positive 5. So look, just add 1 over here. 2x is equal to minus 4. Divide by 2. And one solution is x is equal to negative 2. Which is true. If you plug negative 2 times 2 is negative 4. Minus 1 is negative 5. Absolute value of negative 5 is 5. So it works out. So solve this one. Divide by 2. And another solution is that x is equal to 3. All right, and if you were to plug this in, 2 times 3 is 6, minus 5, minus 1 is 5, and it works out. All right, I just want to show you something that you might see. So suppose you have this. Absolute value of x plus 1 plus 6 is equal to negative 2. Well, look, if you were to subtract 6 from both sides, you get the absolute value of x plus 1 is equal to negative 8. Notice how you can only solve this if the absolute value is equal to a positive number, right? Like the absolute value is never a negative number. So when you see something like this, it means there's no solution. Okay? And that's okay. All right, let's end on one last problem here. We'll do one last trickier one. Okay. So 2 times the absolute value of 4 minus 5/2 x plus 6 is equal to 18. So the first thing you want to do is you want to isolate the absolute value. So you're going to subtract 6 from both sides. Then you're going to divide both sides by 2. Look, you got the absolute value is equal to a positive number. So one solution is that 4 minus 5/2 x is equal to minus 6. So you're just going to solve minus 4 to each side. You get minus 5/2 x is equal to minus 10. Then you're going to multiply both sides by minus 2/5. These cancel. Negative, negative becomes a positive. 10 times 2 is 20 divided by 5. One solution is 4. And then look, you have the other one is that 4 minus 5/2 x is just equal to 6. I'm going to subtract 4 to each side. And then you're just going to multiply both sides by minus 2/5. So these cancel. And you get another solution here is that x is equal to 2 times minus 2 is minus 4 over 5. All right, so we've worked through a lot of equations here. You know, as I said before, if you stick with it with practice, this shouldn't be too hard. And as always, I'm here with questions.